Okay, so now I'm starting the class. So today we will discuss week 10 assignments. Mini assignment questions we will discuss now. Uh, and theory part, if you have any doubts, we can discuss later on. So in last class, we discussed about week 9, where mainly we covered the spraying part, the sprayer related numericals and theory. In last class, we saw that this were the relationship between DMD, pressure and discharge and orifice diameter and surface tension of the chemicals. So you must have completed this lecture. So if you are seeing this from here, you can note down that with the relationship between discharge rate and pressure is given by this equation. This is the relationship between BMD and pressure. This is between BMD and diameter. This is between BMD and surface tension. So this week, like week 10, mainly covers reaper vertical conveyor reaper, that is harvesting equipment. It will harvesting equipment. It will cover harvesting theory part, and threshing will be covered in next week. So in harvesting, uh, harvesting mainly starts from, I think, lecture 47. So uh, the first question is related from the spraying part only. So the first question is, which of the following situation is desirable for achieving a weighted droplet spectrum in carrying out the spraying in groundnut crop? So the option is high relative span factor among droplets, low spray angle of the nozzle, high viscosity of the spraying liquid, low uniformity coefficient of the hole. So have you seen the lectures? What will be the answer? Jigyasa? Which of the following situations is desirable for achieving a weighted droplet spectrum in carrying out a spraying in groundnut crop? So if you will see
Low
lectures,
uniformity coefficient among the drop.
yes, that is correct. Low equality coefficient among the droplets. This question was there this year. You will see later. Okay. Next question is, the nozzle is rated as the nozzle is rated as 0.895 liter per minute at 300 kilopascal. To produce a flow rate of 0.9757 liter per minute, the operating pressure required 1 kilopascal is. So the nozzle is rated at, this is the pressure and this is the discharge. So you can see that this is Q1, this is P1. And to produce the flow rate of this amount, this is Q2, working without rating pressure, you need to know, you need to find Q2. So you need to know the relationship between pressure and discharge. So this you can see that this is the discharge pressure relationship. Q1 by Q2 is equal to Q1 by Q2 is equal to divided into. So from here we can solve it. Q1 is 0.895 by Q2 is 0.957 is equal to P1 by Q2. P1 is 3 by Q2. And this will become square. So P2 will be, what will the value for this? 300 by 0.2.
343 C option.
0.957. And it is coming 343.47.
47.
So for second question, the answer is C. In harvesting, mainly we need to cover this part. Like this is okay. Many slides are left. So mainly this, if you see a harvesting equipment, it is mainly comprised of one knife will be there and one its counters here will be there. Like here it like counter its counters here is laser plate. So and this part is knife guard, and this is laser plate. See, this is guard, this is laser plate, this is laser plate, and this is knife section, sickle section. So what will happen? This knife will do reciprocating motion on this laser plate. So this on this laser plate. So this laser plate will act as a counter shear for this for the stream or for whatever plant is there. So what are the angles associated with this mechanism that we do first see? So if you see this section, like cut section of this knife, we will find that knife is not knife is not placed horizontally, like fully horizontal. It has some clearance. This clearance is provided between the XY plane. Some clearance is provided between this plane and the knife edge plane. So this is called clearance angle, phi ck. So the first angle associated with this mechanism is clearance angle ck. Then second angle is this. This is the edge of the knife, and this is sharpened section. So between this main bottom section of the knife and this sharpened section, this is called bevel angle. PK is bevel angle. And this edge of the knife and the vertical axis, this is called rake angle. So this you can note down. It will come in the answer. I will tell you in details. So these are the angles associated with knife. And bevel angle, this bevel angle is associated with fineness of the knife. How fine the knife is, that is decided by what is the bevel angle. So this bevel angle decides the fineness of the knife section. If bevel angle is more, like if there is more bevel angle, then knife will not be fine, like it will be blunt. And if bevel angle is very less, if this is very less, it then the knife will be very sharp, like very fine with bevels. Then second thing, then the second thing is the sum of this. You can see from this figure only. Sum of this clearance angle, bevel angle, and rake angle. This all sum is equal to 90 degrees. So if two values is given, then you can find the third value. Then next thing is bevel angle plus clearance angle. This bevel angle plus this clearance angle is put together is called chip angle. The chip angle is equal to bevel angle plus clearance angle. Now this is laser part side, this counterpart side, this thing. Here also, this is bevel angle for counterpart, counter shear, and this is rake angle for counter shear. Okay. So next is you need to visualize this thing. So this is knife and this is laser plate. So this is knife and this is laser plate. This knife will go along that laser plate. So there is an angle associated here also. So the first angle which is associated here is, now you make one vertical one. So the knife edge, this is the knife edge with this axis is called, see, this is the knife is and this angle. This is called oblique angle, denoted by OK. And in laser part side also, this is oblique angle in counterpart side, counter shear side. This is laser tube. Second thing is this is oblique angle. So when this oblique angle is straight, means 0 degree, when this is 0 degree, or when this is like a straight here, this edge will be straight, then this is called a straight cut. And then this is not 0, it has some value, it is called oblique cutting. So these are the angles associated with this knife and razor blade. What more things are there? Next thing is clip angle. So this whole angle will be called clip angle, means edge of this knife and edge of this razor blade. This whole sum will be called, this whole sum is called clip angle. So if you understood these angles, then we can solve many questions. In this relationship we saw chip angle, chip angle is this bevel angle plus frequency. So next thing is, this is impact cutting. One plant is there and one impact force, means there is no counter sealing. Means no laser plate or some counter thing is there, just impact. From the force of impact, this plant is going cut. So what is the velocity required? What is the knife speed required that will make this plant cut? For that we have one formula. So this formula you can note down. From here many numericals are there. So this formula comes from this moment equation. So what is the formula for this velocity? Fx minus fb, means Fx is cutting force, fd is bending resistance of uncut portion, and the notices you can see. So, and next thing is the radial load that would cause failure in bending. One more force is there. If this is not in case of, this is in case of cantilevers or simply supported beam. When the plant is acting as simply supported beam, the force that will cause failure is expressed using this equation, where I is the moment of inertia of the cross section, and SU is the ultimate stress of the plant. C is the radius of the neutral axis, and L is the distance from concentrated load to point of support. So I for circular section will be pi t to the power 4 by 64. And what will be the deflection of the steam? So that is given by FRL by CBEI, where FR is the radial concentrated load. So this load, what has come here, that load into L to the power Q, this distance from concentrated load to point of support. So when we solve numericals, we will see that how useful this formula. CB is the constant. In case of cantilever steam, this is 3. In case of simply supported steam, this is 41. And E is the modulus of elasticity of steam fiber, and I is the moment of inertia. Just now we saw that for circular section it is pi d 4 by 64. So next question is, this one is I think in there in the lecture. So during cutting of a brass stem of 3 mm diameter with knife without counter shear, it is loaded horizontally at a distance of 30 mm of the soil surface. Based on the entire stem cross section, the modulus of elasticity is 1600 Newton per mm square. The ultimate tensile strength is 35 Newton per meter per mm cube. So this ultimate tensile strength is SU. This elasticity, modulus of elasticity is epsilon. You have to find the horizontal force that would cause bending failure. So we just now saw that this is the expression for for horizontal force that will cause bending failure is given by ISU by C into L. So the horizontal force that will cause failure is I SU by C into L. I is the moment of inertia. I is for circular section it is pi d 4 by 64. Diameter of this glass steel is 3 mm. Every dimension is in mm, so we just need to put the value. So pi into 3 to the power 4 by 64 will be I. Ultimate strength is also in Newton per mm square, so directly put it here. C is the radius of this glass steel. So radius will be 3 by 2. C will be 3 by 2 and L is the distance from concentrated load to point of supply. So here it is given. It is 30 mm, 30 mm the charge surface. So this is the distance from concentrated load to cut. So L will be 30 mm. We just need to put all those values. We can get what is the force required. So it will be pi 3 to the power 4 by 64 into 25 by C. We do this calculation, what is the answer? Next slide.
3.09.
It is 3.09 meters. Next part is the horizontal deflection of the steam. So horizontal deflection of the steam is given by FRNQ by CP on FRNQ by CP. So this force is 3.09. And is the distance from concentrated load to point of support, that is 30 mm. So this is 30 mm cubed by Cp. Cp is the constant for 3 for cantilever steel. So this is acting as a this will act as a cantilever steel. So it's will be 3 and I is this way.
Sir, unit of L will be in millimeter only, no?
This is millimeter. This is I will come in millimeter. Yes, everything you can put in millimeter. So
Sir,
deflection will come
it's
in
7,132.8.
7.
713.8.
Okay. This is the
This
deflection.
is 7132. 2.4 digit. Yes.
This 7 meter.
Yes, sir,
Yeah.
yes. This much but converting it will be meter. But how?
It should come as 4 mm. Okay, you use this formula besides C. This. Have you done calculation correctly? Okay, so it should come around 4 mm. Approximately 4 mm is the answer. So 4.576 mm. So this is the deflection when that force is being acted and that and so the horizontal deflection of the steel at point of failure will be this. So next question is the value of real speed index. This you have studied from like what is the real index? What is real index first you tell? You know what is real index?
So in case of combined harvester,
So
the uh, so definition I don't know actually the link.
this real is there. This is velocity, like forward velocity of reel will be something. Velocity of reel and velocity of whole combine or whole machine will be something. So the ratio of this velocity, this real velocity by velocity of machine is called real speed index. So if it is greater than a certain value, then there is a problem, and if it is less than certain value, then there is a problem. So the optimum real index, which has been found from many experiments, is between 1.25 to 1.4. 1.25 is lower limit and 1.5 is upper limit. So if it is lower than 1.25, what will happen? You just think.
The crop will wrap around.
Like it will not able to gather the crop if it is lower than this value. And if it is greater than 1.5 value, then what will happen? Scattering loss will be more. Like if the plant is uh, due to the speed of this reel only, the plant will fall. So that is solution. So optimum value for this speed is 1.25 to 1. So between this real speed index will be low. So the answer here will be C. So next question is we have to match these two points. So angle formed between the knife and counter seal. It has not been described here in this figure. So the angle formed between knife and counter seal. Counter seal is the laser. So one knife is there and laser plate is there. We have just seen this angle. So angle formed between this knife and
Clip
this.
angle.
This is called clip. Correct.
Clip
Fineness of the knife is determined by which
bevel bevel angle.
angle formed between the bottom edge of the knife and XY curve. Bottom edge of the knife. So this is bottom edge of the knife and this is XY curve. So if you're considering
Clearance
this,
angle.
so this is close. And the sharpness of the knife is determined by this radius. This circle is there. So this radius determines what sharpness, how sharp the knife is. So sharpness is determined by the knife edge radius. So what do you answer? D, A, D, C. D, A, D, C. So, C will be checked. So next question is a straight cut is one in which
Zero
oblique angle is
zero oblique angle zero.
this this is the oblique angle, and when it is zero, it is called a straight. So next question is the knife of a standard cutting unit used in vertical conveyor linter in proper register. So two things are there when we study harvesting. So one is registration and one is alignment. So a reaper is called improperly the proper registration, in which case we call it is that it is properly registered. Do you know that?
The alignment will be like the center of both will be equal. Like they should fall on each other.
Which ones we follow each other?
The uh, knife and the supporting that one.
So at every like after every action, if the knife is cutting at the centered point of guard, then it is called properly registered. So midpoint of the stroke is centered between adjacent curve. Treatment and knife are not in line. Midpoint of the head is up. The stroke is centered between a knife point. So midpoint of a stroke is centered between
A
adjacent curve. So A recruit. And when it is called properly aligned, when we call it, when we call that paper is improper aligned. Like this pigment is there, this cutted bar is there, on which knives blade are there. When this like this sex when from you will see from the side, like this repair machine is there. When you will see from side, then this pitman, this cutter bar, and this is called crank wheel. This crank wheel, they all will be there in same line. We call it properly aligned. So for like making it in a straight line while cutting, what is generally done? A lead of 2 degrees given. So when the plant is here, when it when this will cut it, so this cutter bar will move backward. So for compensating that backward movement, a lead is given of 2 degree. This 2 degree forward lead is given so that it will while cutting it will be proper alignment. So next question is for carrying out cutting of plants by knife with counter shear. Without counter shear, it is cantilever. Just now we were discussing that question. So with counter shear, it is there. The plant is still below the plane of cutting is loaded as.
simply supported.
Simply separated. This is the plant. This is cutting. On this side, laser plate is there. This counter shear is there. So they are seeing that for cutting out at this section. Means for this section, what will be there? For simply supported, there is no radial loading. But in case of plant, there is a radial loading. So the answer will be simply supported beam, but with radial loading.
With red body.
To see radial. So next question is during cutting of forest crop of a steam diameter 15 mm by impact force, it is loaded horizontally at a height of 30 mm over ground. The mass of plant above cut is 0.02 kg and the knife speed is 4.2 meter per second. The height of center of gravity of the cut portion above plant plane is cutting is 30 mm. With the bending resistance of a stump is 18 Newton, a force applied by knife in Newton. So that formula we will have. K is equal to root under Fx minus Fw into that formula
ZC into B by Z.
Zc into T by
B
Zc
sir
is
B. B was there. ZCG into MP into 1000.
correct. So this can be literally posted. So the question being asked is what is the value of force applied by knife? Force applied by knife is this Fx. We need to find this Fx. Bending resistance is 18 Newton. This is 18 Newton. The mass of plant cut is 0.02 kg. This is 0.02 kg. If you convert it in Newton, then cutting steam diameter is 15 mm. So this is 15 mm. It is loaded horizontally at height of 30 mm per plant. So this ZC is 30 mm. The mass of plant over 30 is 0. The speed is 4.2. So this speed is 4.2 meter per second. The height of center of gravity of cut portion over plane of cutting. So ZCT is 30 mm and ZC is 30 mm. The bending distance is 18. That is in this efforts. So everything is given. So Fx will be Vk square times Vk square into HFC plus HFCC and into 1000 entire HFC into 2 is so therefore Vk square is 4 into square 30 plus 30 into 0.02
Sir, 479 that answer.
into 900 into 100,000 HFC into so what answer you got?
479.46.
Okay, this okay. So correct answer is D. So next question is the height of rings would be made adjustable to a this is regarding the question. So height of
All
rings,
the
height of
all,
plane and cut, height of cut, and splitting. So this is like you can guess it also the height of rings should be made it still to accommodate everything like height of cut as well plant cut also, heat splitting also. Because if it is less height, then these two will not be follow. So correct answer will be. So next question is the wear plate of the knife section in a conventional mode provides
both vertical support
vertical
and
support of the plate
of rear knife section.
and the vertical support of the knife section which also is yes. So the correct answer will be. So this was the question for regarding big time. So we solve big 10 questions. The deadline is day after tomorrow. You tell that if you face any problem. So big nine in your you didn't get any problem.
No, no, no problem. Like one question was there, only same formula it was there, whatever we discussed, but in this the like different approach was there. Like the formula will be same, little bit twisted.
Do you have any doubts regarding these questions?
No, sir, I have to complete it. Like I have not seen like 47 only. I have seen 46, 47. I have up to 50. I have to watch. So
Okay, you see those lectures. If you have any doubt, we will discuss it later.
yes, so one question it has asked that which of the following situation is desirable for achieving that only like here the question number 2 was there from for a certain crop was there, but in this week it has been given that which of the following situation is desirable for achieving a better droplet of an agricultural sprayer.
Important answer.
So the options are a high relative span factor among the droplet and low spray angle of the nozzle. Then C is high viscosity of spraying liquid and low uniformity coefficient among the droplets.
We have solved this question in this in previous class.
That crop was given here. Groundnut for groundnut was given.
This week question, like just now, first question is solved.
Ah, yes, yes. Second, first or second, probably.
Mhm. This one, no?
It was for groundnut crop, but here they have given like for agricultural crop like
Oh,
that only.
okay, okay, okay. Same answer would be during community coefficient on the problems.
The rest, all the numericals are only from this formula only. like whatever we discussed now. So I'll do.
numerical same.
Like
Numerical
not
same.
exactly same, but the format is same. Like what will be the deflection and all they have asked.
Okay. This you will not find face any problem. This.
Yes, sir.
Okay, then from this discussion you can solve written questions. I think.
Yes, sir. Yes, sir.
Okay, then we will written next week. Okay.
Sir, only the marks part is, if possible, please tell me so that yeah, for final exam it will be helpful.
Okay, then Jigyasa will leave.
Okay, sir.
So we will solve the questions where we left in last week. We were discussing about vertical conveyor reaper and harvesting. So this question we were discussing, and we will resume this question. So the question is, if forward velocity Vf is 5% of the blade peripheral velocity for rotary mover, determine the maximum oblique angle phi OP and the blade angle theta at which it occurs. So for this, we need to find that we must know that what is the relationship between this oblique angle and the blade angle, and also this forward velocity and peripheral velocity. So the equation which defines all this parameter is tan phi OB is equal to VF cos theta by VP minus VF sin theta. So as you can see here, is theta is the blade angle, VF is the forward velocity, 5% of the blade peripheral velocity. VF is the forward velocity and VP will be the blade peripheral velocity. So VF is equal to 5% of the blade peripheral velocity. VF is equal to 1.05 VP. So this will be used later. For now, we have this expression and we are asked that determine the maximum oblique angle phi OB. We need to know that what is the maximum oblique angle which we can obtain and what is the blade angle, what is the theta at which it occurs. So in basic 12, 11, 12 mathematics, we have studied that for maximizing in maximum case, we use derivative, we derive, uh, we find the derivative of function and equate it with zero, and the variable we get is the maximum or minimum value at which it occurs. So if we will differentiate this function, that is tan theta OB with respect to theta, we will get theta at which the maximum phi OB is occurring. So we will proceed with the derivative. So d tan phi OB is equal to d by d theta Vf cos theta by Vp minus Vf sin theta. So as you remember, what is the derivative of x by y or v by u? It is v into du by dx minus u into dv by dx by u square. This was the basic formula which we have studied in our school days. So we will use it here. So first we will keep this denominator, that is vp minus vf sine theta, and what will be the differentiation of vf cos theta? It is minus vf sine theta, and minus sign will come, and we will keep vs cos theta, and we will differentiate the denominator, and it will become minus vf cos theta, and denominator will become vp minus vf sine theta whole square. So this is the differentiation of our function with respect to theta, and we will equate it with equal to 0. So what we will get? We will get is vp minus vp vf sine theta plus vf sine square theta plus vf square cos square theta is equal to 0. This is the equation we are getting, and this theta will give the blade angle at which maximum oblique angle will occur. So this will become minus vp vf sine theta plus vf square sine square theta plus cos square theta is equal to 0. And now this is 1. So minus vp vf sine theta plus vf square is equal to 0. So from here we can see that sine theta value is vf by vp. So sine theta is vf by vp, and vf by vp, there is a relation which is given in the question. vf is 5% of the vp. vf is 5% of the vp means vf is equal to 0.05 vp. So vf by vp will become 0.05. So equal to 0.05. Now we need to find the angle at which this value is coming. So theta will be equal to sine inverse 0.05, and the value of sine inverse 0.05 is approximately 2.866 degree. So this is the blade angle at which maximum oblique angle phi OB occurs. And what is the value of that maximum oblique angle? That we can find by putting this theta value in our equation, which defines all those notations. So tan phi OB is equal to tan phi OB is equal to Vf cos theta by Vp minus Vf sin theta. Okay, so we need to put the theta value here, or we can also see that we have sin theta and cos theta expressions here, which we can directly put it here. So sin theta we already have Vf by Vp, which is nothing but 0.05, and cos theta, as we know that cos theta is root under 1 minus sine square theta. So it will become root under 1 minus 0.05 square. So cos theta value will come root under 1 minus 0.05 square. So it is approximately 0.9987. So sin theta is 0.05 and cos theta is 0.9987. You will put it here. Cos theta and sin theta value we know, but PF and VP value we don't know. So what we can do, we can make everything in terms of VF or VP. So that term will get cancelled out. So suppose VF in terms of VP, if we will put, so we have VF by VP is equal to 0.05, means VF is equal to 0.05 VP. So 0.05 VP into cos theta is 0.9987 by VP minus 0.05 VP sin theta, and sin theta is nothing but 0.05. From here, what expression finally we are getting is 0.05 into 0.9987 by 1 minus 0.05 into 0.05. This is the final value of tan theta, tan phi OB, and when we will do the tan inverse of this value, we will get the final phi OB. So we will do this calculation. 0.05 into 0.9987 divided by 1 minus 0.05 into 0.05. It is coming as 0.05. So phi OB will be equal to tan inverse phi OB will be equal to tan inverse 0.05, and this value is again 2.866. So what is the blade angle at which maximum oblique angle is happening? Blade angle is equal to 2.866 degree and maximum oblique angle is equal to 2.866 degree. So the value of both angle is same, and it is 2.866 degree. So this question we had left earlier. Now we have solved this. Next is estimate the power requirement of a disc type rotary mower which has 6 discs with 4 blades in each disc, and each cutting a width of 0.4 meter with an overlap of 4 degree between adjacent discs. The blades are sharp and the travel speed is 15 km per hour. Assume the specific power loss is 1.5 kilowatt per meter of a disc and the specific cutting energy is 1.7 kg per meter square. So how we will solve the question? For this we need to know the expression for total power requirement. So total power requirement is given as PS into PS plus ECA into VF into W. So this is the expression for total power requirement. and given value is PS. PS we are given as 1.5 kilowatt per meter, and cutting energy, the specific cutting energy we have also given is 1.7 kilojoule per meter square. Now forward BF is the forward velocity, which is 1.15 kilometer per hour. So 15 kilometer per hour we will convert it in meter per second. So 15 by 3.6, it will come as 15 by 3.6, which is 4.167 meter per second. Only left thing is W. So for cutting width, we need to know the actual cutting width. So there are 6 blades, there are 6 discs, and each having a width of 0.4 meter. So theoretical width, what will become? It will become 6 into 0.4. So it is 2.4 meter. And we have an overlap of 0.4, we have an overlap of 4% between adjacent disks. So what is the total overlap that we will subtract with this theoretical width of the rotary motor? So total overlap we have is 4%, that is 0.04 of 4% between adjacent disks, 0.04 of this 0.4 meter. So this value is overlap of between two adjacent disks, and there are how many overlaps will be there? As there are 6 blades, so 5 overlaps will be there. So 5 into 0.4 into 0.04. This is the total overlap which we need to neglect to find the actual width. So 5 into 0.4 into 0.04. This becomes 0.08. So what is the actual width, which has been denoted as W here? Actual width W is equal to 2.4 minus 0.08. It is nothing but 2.4 minus 0.08 is 2.32. We directly need to put this value in our PT. So PT will become 1.5 kilowatt per meter plus 1.7 kilojoule per meter square into 4.167 meter per second into 2.32. So this value will come in kilowatt, as everything is there in kilowatt and kilojoule, and every other unit is in meter and second. So all units are balanced. We just need to solve this calculation. So the final value will become 1.5 plus 1.7 into 4.167, 8.5839 into 2.32. So it is coming as 19.91 kilowatt. So what we have solved this question. What it was asking? Estimate the power requirement of disk type rotary motor, which has 6 disks. So the total power requirement will become 19.9 kilowatt. So I hope this is clear. So this was again the question from vertical conveyor reaper. Next question is again from rotary motor, and it is given that consider a disk type rotary motor that has 6 disks, each cutting a 0.4 meter width. The motor is traveling at 15 km per hour. These things are same as ever. And if the specific power loss due to air, stubble, and gear train friction is 1.5 kilowatt per meter of cutting width, and a specific cutting energy is 1.5 kilojoule per meter square for sharp blade and 2.1 kilojoule meter square for worn out blade, estimate the PTO power requirement if the blades are sharp. First question is we need to estimate the PTO power requirement if the blades are sharp. And second question is estimate the PTO power requirement of the same mower after the blades become worn. So we need to know the expression for, or we need to know that how we calculate this PTO power requirement. So what we have given here in this question is, so number of days are 6. So I'll write all the parameters which have been given in the questions. So number of days is 6. Cutting width per disc, cutting width per disc is 0.4 meter. Forward velocity is 15 kilometer per hour. 15 kilometer per hour means 4.167 meter per second. So this is 4.167. The specific power loss, the specific power loss, which we can denote as PLS. The specific power loss is 1.5 kilowatt per meter, and forward velocity VF is 4.167. And next thing given is a specific cutting energy. So E dash we are denoting for a specific cutting energy, and it is 1.5 kilojoule for sharp blade. For sharp blade, it is 1.5 kilojoule per meter square. So we were discussing that what is the PTO power requirement for sharp blade and blunt or bond blade. So we have this power loss, specific power loss in kilowatt per meter given, and we have this specific cutting energy given in kilojoule per meter square. And we have just discussed the formula for power requirement for PTO, which is PS plus E into PF into W. PS plus E dash to VF into W. So first, if we are calculating for sharp blade, then E dash for wand blade is 2.1 kilojoule per meter square. So what is the power requirement for sharp blade? PTO for sharp will be equal to PS. PLS we are writing here. So PLS is 1.5 plus, it is in kilojoule, 1.5 into VF. We have already calculated it as 1.6167 into width. So width here directly, there is no overlapping given. So we will directly multiply 6 into 0.4, it is 2.4 meter. So width is 2.4 meter. So what will be the value for this calculation? 1.5 into 1.5 into 4.167 into 2.4. It is 22.5018 kilowatt. And power requirement for PTO in case of worn blade will be 1.5 plus a specific energy requirement A specific cutting energy will change. It will become 2.1 into 4.167 into 2.4 meter. So it will become 1.5 into 1.5 plus 2.1 into 4.167 24.601. And here it is 18.6, not 22. 18.6 kilowatt, and here it is 24.6. So you can see the difference. In case of bond blade, the power requirement is increasing by approximately 6 kilowatt. So this is the question to from where we can estimate what is the PTO requirement for same or if the blades are sharp and if the blades are worn. So next is again the question for vertical conveyor ribbon of this week. And the question is, in a VCR with a cutting width of 1.2 meter is used to carry out harvesting of paddy crop at a forward speed of 1.2 kilometer per hour. The hill to hill spacing of paddy crop is 20 into 20 centimeter and average hill diameter is 26 mm. If the specific cutting energy is 0.065 joule per mm square, find the total power required for cutting paddy crop. I think this question we have just discussed few minutes ago. So we will move to the next question. The next question is, during cutting of forest crop of a stem diameter 15 mm by impact force, it is loaded horizontally at a height of 30 mm above ground. In cutting of a stem diameter 15 mm, diameter of stem is 15 mm by impact force loaded horizontally at a height of then 30 mm above ground. The mass of plant above cut is 0.02 kg. Mass of plant above cut is 0.02 kg and knife speed VF we generally denote as knife speed and it is 4.2 meter per second. The center of gravity CG of height of cut of plant above ground is 30 mm. Calculate the force applied by knife causing a failure. The ultimate tensile strength of forged steel is 35 Newton per mm square. So by with standard notations, what we are given is this question we have not solved. First we will solve this question, then we will again move to the other question. First we are solving now this. So here steel diameter is given, cutting height ZC is given as 30 mm, mass of plant cut is 0.02 kg, knife speed VK is 4.2 meter per second, ZCG. ZCG we are denoting as center of gravity. Height above cutting plane is ZCG. It is 30 mm. Ultimate tensile strength of a steam S is given as SU is 35 Newton per mm square. Calculate. We will first calculate the bending force. So for calculating bending force, we need to use this tensile strength of forged steam, which is given as SU is equal to M into Y by I. This we have studied in the starting slides, SU is equal to My by I. Now M will be our FB into the distance at which we are performing the cut. So FB into cutting height, that is ZC. M is equal to FB into ZC, and Y is equal to D by 2, where D is diameter. So D by 2 is equal to 7.5 mm. And I is the moment of inertia, which for circular section is pi d 4 by 64. So it will become pi into diameter is 15 mm to the power 4 by 64. So from here we can calculate what is the value of FB. So in this expression we are obtaining 35 is equal to FB into 30 into 7.5 by pi into 15 to the power 4 by 64. So by solving this, we can get what is the value of FB. So FB will become 35 into I into 15 to the power 4 by 30 into 7.5 into 64. This will come in Newton. So while performing this calculation, we will obtain 35 into 3.5 into so this is coming as 386.37 Newton. So FB value, that is calculated bending force. So FB value, that is bending force. Bending force value is FB is equal to 386.37. So from here we will move to the next part. That is calculating the inertia force component, that is Fx. So from the equation which we have studied in the initial slides is Vk is equal to Fx minus Fb into Zc into diameter by Zc plus Zcz into Mp into 1000. So with this expression we can solve that question. Fx we need to find out. So Fx minus 386.37 into Zc is 30 into D is 15 by 30 plus 30, this is Vk square. 30 plus 30 into Mp is 0.02. We need to convert it in Newton, that is 9.81 into 1000. So, and Vk is also given. What is the value of velocity at which it is cutting? 4.2 meter per second. So this is 4.2 square. So what will be the value of Fx? It will become 386.37 plus what value? 4.2 square into 30 plus 30 into 0.02 into 9.81 into 1000 by 30 into 50. So this is 386.37 plus this value. This is 4.2 into 4.2 into 16 into 0.02 into this is coming as 47.04. 47.04 Newton. And this bending force was coming as 386.37 Newton. So total cutting force will be equal to 386.37 plus 47.04. 47.04 plus 386.37. It is equal to 433.41. Approximately 433.41 Newton is the force applied by the knife causing the failure. Is the force applied by the knife to cause the failure if the ultimate strength is 35 meter per mm square. So if you are knowing the expression, if you need to remember two equations for this problem, that is this velocity formula and this ultimate strength of the force. This formula, these two formula, if you are remembering, you can solve this question easily. So next question is, we had left some questions in fertilizer and pesticide application. So this question is related to agitation, that is very important for your exam and important for your conceptual clarity. So we will solve this question 1, 2 and 3 question, then we will end this class. So first question related to the left section was, a side dressing fertilizer distributor is to place 2 bands per row on a crop with 1 meter row spacing. It is desired to apply a fertilizer having a specific gravity of 0.85 at a rate of 560 kg per hectare. If the distributor is calibrated by a driving the machine forward at a distance of 30 m, what mass and volume of material should be collected from each delivery tube when the distributor is properly adjusted? So the row spacing is 1 meter. Calibration distance, I'm writing all the things which are given here, so you can also make the notes later. So the things which are given are, row spacing is 1 meter, calibration distance 30 meter, application rate is 560 kg per hectare. Application rate I'm writing as AR, it is 560 kg per hectare. The specific gravity of fertilizer is 0.85 and number of bands per row is 2. Number of bands per row is 2. So first we will calculate the area covered during calibration. So area covered during calibration. So what is the area covered during calibration? Two bands per row and with 1 meter row spacing. So row spacing and this, if the distributor is calibrated by driving machine forward at a distance of 30 meter. 1 meter row spacing and 30 meter forward distance it is covering. 1 meter and 30 meter. So what is the area covered? 30 meter square. So area covered during calibration is 30 meters square. Okay. Then we will calculate the total mass of the row. Total mass for each row will become total mass for each row. So total mass for each row will become application rate by application rate into calibration area. Application rate, what it is given, it will be in kg per hectare into this area covered during calibration. So this will become total mass in each row. So this in hectare, this in meter square. So we have 560 kg per hectare. 560 kg by 10,000 meter square into 30 meter square. So it will become 560 into 30 by 10,000. So it is 1.68 kg. This is the mass of fertilizer for 1 row. Now there are 2 delivery tubes per row. So this mass is for 2 delivery tube. So mass per tube, what will happen? Mass in each tube will become 1.68 by 2. It is equal to 0.84 kg. So this is the mass in each tube. Now we need to calculate the volume per delivery tube. So what will be the density of fertilizer? For density of fertilizer, we will use that specific gravity that is given and multiply it with density of water. So density of fertilizer will be the specific gravity of that fertilizer into density of water. So specific gravity is 0.85 and density of water is 1000 kg per meter cube. So it is 850 kg per meter cube. So density of the fertilizer is this much and mass in each tube is 0.84 kg. So from here you can easily find what is the volume in each tube. So volume is equal to mass by density. We can directly put volume is equal to mass by density and mass is 0.84 by density is 850 kg per meter cube. So this will come in meter cube. So it is coming around 0.84 by 850. It is 0.00098 meter cube. And if you want in centimeter cube, it will become 10 to the power 6 centimeter cube. So it will become 988 cc. So this is the volume in each tube that was asked. So what we needed to find, what mass and volume of material should be collected from each delivery tube. So this is a calibration question where this amount should be calibrated, this amount should be collected if you are collecting the volume, and this amount should be collected if you are doing the mass for each tube. So I hope this question is clear to you. And next question is very conceptual regarding agitation. So here it is asked that a round bottom sprayer tank is 1.4 meter, 1.5 meter long and has a depth of 0.9 meter. Mechanical agitation is to be provided with 4 pedals 280 mm long and 200 mm wide, mounted on a shaft of 150 mm above the bottom of the tank. So first thing which we need to find is calculate the minimum speed of the shaft. And for that we have given a formula. Minimum peripheral speed of paddle in meter per minute is this one, where A, R and F, E, L, all notations have been defined here. A is the depth of liquid above agitator shaft in mm. You need to care very carefully as this can damage all your calculations. So you need to take care. R is total combined width of all pedals divided by tank length. So here division with tank length is there. Fe is the agitation factor. Agitation factor, I think here it is given. If someone is asking you this question, then he must give this table that what is the agitation factor, and he must also tell that what is the percentage of water and emulsifier and oil. So this 3% they must tell, so that you can know that what Fe value you need to put. So F is the agitation factor. This three value you require for knowing the minimum speed. So we will go step by step. First, we will calculate what is the minimum speed Sm, which is equal to 5.39 into A. What is the depth of liquid above agitator shaft? So first we will write what all things are given. So A is given as depth of liquid above agitator shaft. Depth of liquid above shaft is, see, it has a total depth of 0.9 meter mounted on its, and this agitator is mounted on a shaft 150 mm above the bottom of the tank. And A, what is A? A is the depth of liquid above agitator shaft. So you need to be very careful here to find the value of A. Suppose this is tank and this is agitator. So A value is this one. So total depth is 0.9 meter, and the shaft is mounted as 150 mm. So what is the value of A? If you are writing in centimeter, then it will become 150 by 900 minus 150. So this is 750 mm. So A value you obtained as 750 mm, and next variable is R. So R is total combined width of all paddles divided by tank length. So number of paddles into width, that will give you number of paddles into width, that will give you total combined width of all paddles divided by tank length. So number of paddles is 4 and width of paddle is 200. In centimeter we are writing everything now, and tank length is 1500 mm. So R value will become 0.533. Now you can directly put an FE. For FE, you need to know that what they have given about oil and water percentage. So it is given that mixture of 10% oil and 90% water. So this is the row which we are referring, and Fe value will become 0.89. So now we are knowing all the values to find this Sm. So Sm will become Sm is equal to 5.39 into A, that is 750. A we have to write in mm, so it is 750 to the power 0.422 by R. R is 0.533 to the power 0.531 into Fe. F is 0.89 to the power 0.293. To do this calculation, when we will solve this, we will get what is the minimum peripheral speed of paddle in meter per minute. So this value will come as 5.39 into 750 to the power 0.422 divided by 0.533 to the power 0.531 into 0.8 to the power 0.28. So this is coming as 118, right? Yes, it is coming as 118 or 119. It is coming approximately as 119 meter per minute. So this is in meter per minute. Now, if you want to know the shaft speed in terms of RPM, then RPM you can easily get it as this is in meter per minute. Divided it by pi d. Pi and d is equal to meter per minute. Getting velocity is equal to pi and d. So from here you can calculate what is this n. So RPM will become Sm by pi d. So Sm is 119 by pi into what is the diameter? 0.28 meter. So you can see that tip diameter given is 280 mm long. And this is in meter per minute. So you can put it directly 0.28 meter and you will get 135.4 rpm. So this is the minimum peripheral speed in rpm. So first part is called minimum speed of the shaft. Second is if the mechanical efficiency of power transmission is 90%, what input power would be needed for agitation? For that, one expression is given. We don't need to remember. If they are asking, they must give all these notations here. We just need to use those notations. So if this expression they must give. So this expression, from this expression, we can calculate what is the mechanical efficiency, what is the power transmission, what is the input power. So input power is given as PS is equal to 3.26 into 10 to the power minus 11. So second part, for second part we have ES is equal to 3.26 into 10 to the power minus 11 into R to the power 0.582 into Sm to the power 3.41 into L. So this expression we need to use, and for this we have 3.26 into 10 to the power minus 11 into R value we have calculated as 0.533 into 0. To the power 0.582 and Sm we have calculated as 119 meter per minute. We will put it directly here. And L, what is L? L is the tank length. That is the tank length in meter. So in mm, so it is 1500 mm. So while solving this, while solving this calculation, you will get PS value as 0.402. 0.402 kilowatt you will obtain. And input power needed is 90% of the transmission efficiency. 90% of the transmission efficiency is there. So this is 90% of the. This is finally we are getting this 10% power transmission loss is there. So this value is 0.9%, 90%. So what is the initial input power given? That is 0.402 by 0.9. So input power given will be 0.447 kilowatt. So this is the second part of the question. Third part they are asking is, for the above condition, what circulation rate would be required for carrying out hydraulic agitation at 400 kilopascal? So for that also there will be an expression, that is, this expression is there where minimum total recirculation rate in liter per minute is given by this equation. So Qm is given as 3830 VFE by P to the power 0.56. Here V is the tank volume. V is the tank volume, volume of tank is V. So this will become tank length into area of round bottom. So if we are calculating in meter, this will become 1500 mm. So 1.5 meter into 0.9 into width. So area will be pi r square or pi by 4 d square. So here you need to use pi by 4 d square. And what is the value of d? D is it is round bottom, so it must have some diameter. Volume of tank, you can calculate it as pi by 4 d square into depth. This will be the best way to calculate the volume, I think. And diameter will you can take as the length of shaft, because length of shaft is there in that round tank. So pi by 4 into 1.5 meter you can do square into depth, and depth is given as 0.9 meter. So it is 0.9 meter. You calculate this volume. It is coming as 1.59 meters square. It is 1.59 meter cube. So volume should be in meter cube. If this is in meter cube, and pressure in kilopascal. 3830 1.59 meter cube, 1.59, and FE. FE is 0.89 into 0.89 by pressure is 400 kilopascal. 400 to the power 0.56. You do this calculation and you will get the answer maybe approximately as 107.07 liter per minute. So this is the minimum total recirculation rate that would require for carrying out this hydraulic agitation. Earlier it was mechanical agitation, and if in case of hydraulic agitation, what will be the circulation rate, minimum circulation rate required, it will be, we will use this formula in case of this hydraulic agitation. And next thing is, if the pump efficiency and transmission efficiency are 50% and 90%, what pump input power would be needed at this pressure? So pump efficiency and transmission efficiency is 50 and 90. So D part is efficiency of pump, efficiency of transmission is 50 and 90%. So what will be the input power? So for that, you can directly calculate what is the hydraulic power, and then we will divide these efficiencies, and we will get the input power. So what we need to first know, what is the hydraulic power we are getting. So hydraulic power, that is denoted as PH, is discharge into pressure. So discharge QM into pressure is P divided by 60 into 1000. If we are doing, then QM should be in liter per minute and P should be in kilopascal. If QM is in liter per minute, P in kilopascal, you can directly use this formula to get what is the hydraulic power. So QM we are having 107.07 liter per minute, and pressure is 400 kilopascal, divided by 60 into 1000 we will do, and we can get the hydraulic power as 0.714 kilowatt. So this is the power we are getting, and this is result of transmission and pump efficiency. So we will what will be the input power? Input power, the input power will be 0.714 by 0.5 into 0.9. So this value you will finally get as 1.586 kilowatt. So this was the question, and if you can solve it by your own to get your conceptual clarity. This consists of many concepts, so you solve it by your own at your home. This class has already become lengthy, so we will end this class here, and I hope you have understood the class, and if you have any doubt, we will meet in the next session. Okay, thank you. This question we will solve in the next session maybe. Okay then.